Thanks, everyone. Thanks for coming. All right, I'm going to talk about ultra-high throughputs, and I only call it that because it's spelled UHT, and it's fun. But we're going to talk about rollups, and we're going to talk about scaling Tezos. And I think you've all heard about scalability. We're in an industry where people talk a lot. People have talked about scaling blockchains. We've heard about this for about 10 years, and people talk about it. It doesn't really happen. And so we did something a bit crazy. We're actually making it happen. So let me remind you a little bit about Tezos in a nutshell. Tezos is a project that started in 2014, launched in 2018. It was born with proof of stake. It was the first major smart contract platform launching with proof of stake and economic incentive. We are a pioneer in proof of stake. We're a pioneer in governance. But what has guided us through all these years have been decentralization. It's a big decentralized network. There's many teams who contribute to the code base of Tezos. Security, the chain has been live. It doesn't go through outages. It has been stable for now 5 years. And upgradability through decentralized governance. Tezos does not upgrade by some dictator's decision or the idea that, oh, you have to install this hard fork, follow everyone. No, it proceeds by votes. Everyone can be involved in the governance of Tezos. So it's a real decentralized network, but it's not just about governance, it's about innovation. So rapid evolution, easy edge for Tezos. If you want to think about Tezos, yes, Tezos is a layer 1. Tezos is a place where you will see most of the generative arts, NFTs, but it's also a rapidly evolving blockchain. So it's upgraded progressively over the past 5 years with 14 upgrades, all of them involving a vote of the community. It has a streamlined and time-tested on-chain mechanism for upgrading. A single implementation which keeps things simple and which lets us go really fast. And a lot of teams, this is not just a single team working on Tezos, it's many teams throughout the world collaborating to build Tezos and make it the best platform there is. So what's important is adapting as tech improves and as the world changes. And this was the founding idea behind Tezos. It was 2014, I was looking at everything that was happening in this space. We had smart contracts being developed, proof of stake was being looked at, zero knowledge solution, privacy. And how could you design a blockchain that would stand the test of time, that would have the ability to continuously get benefit from that? And scaling is one of those recent things that has basically finally been solved. So what have we achieved? We hot swapped the consensus algorithm. This was 2 years ago, actually. We had moved from a consensus algorithm that was not semi-synchronously safe to one that was. What did it do in practice? Why do we care? Well, it's letting us reduce the block time. Tezos started very conservatively with a block time of 60 seconds, now 15 seconds, and it's been halving and going down and down. Smart rollups. So we're a pioneer of rollups in the Tezos ecosystem. Now you've heard of rollups, you maybe have heard of optimism, Arbitrum, so rollups are very hot now. A lot of people are building those. What we did is we actually implemented rollups. So the rollups in Tezos have fraud proofs, they're secure, they're not backed by a multi-sig, they're real decentralized rollup. We're doing a very silly thing, which is we're actually implementing the technology that other people are talking about and pretending to run. Adaptive issuance, changing the staking economics of the chain, and the data availability layer. So essentially the way that Tezos can scale is by moving a lot of the activity that is happening on the chain off the chain. So it can mean having your computation happen off-chain in a roll-up. It can mean that your data, instead of being stored on the blockchain, can be shared across all of the validators. So these are technologies which are real, which are actually shipping now in the Tezos network. But why are we doing all this fundamentally, right? Well, at the end of the day, Tezos is an application platform. It also powers a cryptocurrency. But what do people want as an application platform? Well, they want performance. And by that I mean they want a platform to be stable. They want a platform to work. And also they want to have, they don't want to pay $30 or $8 even for a transaction. They want to be able to do millions of transactions and pay pennies for those. They want composability. They want an ecosystem where contracts can talk to each other, can interact, and that's the beauty of this. Why build on blockchains and why not build on database? Well, in some cases, you do that because you really need that censorship resistance. You have this very subversive use case. But in many cases, you just want to be part of an ecosystem. You want to be able to interact with the different contracts with an entire ecosystem. Decentralization, that's to keep it robust. Interoperability, very important. You want to be able to use many different languages. You want to work with the code that you already have. And fundamentally, a good developer experience. As a developer, you know, I'm a developer myself. I don't want to be wasting time having to go through a lot of doc, understanding something very complicated, or taking the risk of writing catastrophic bugs in my code. So I want a good developer experience. So we'll get to how we can do that. So first, scale execution. That's the first thing we did, and that happens with smart rollups. So smart rollups is the name of rollups in Tezos. They are not they are not some solution built by a company external to the protocol. They're an integral part of the protocol. So the simplicity for a developer of the Tezos ecosystem is that it's all integrated. You have a vertical integration between the layer 1, the layer 2, the data availability layer, and you don't need 20 different tokens that you have to buy from a VC to do that. You do it directly on Tezos. So we've built that, and we're scaling execution with rollups. And in particular with the launch of a EVM-compatible rollup called EtherLink. Now, once you've scaled execution, you want to scale bandwidth. How do you do that? Well, you can have data availability committee. They are groups of people who can keep the data off the chain. That's not a bad solution. There's a lot of use cases where that's actually a good choice, but it's not the most decentralized solution. If you want the most decentralized solution, we're building a data availability layer. Now, that's a technical term, and in fact, data availability is not a really good name for it. Some people have heard of it in the Ethereum world. They call it dank sharding, which is a funny term. But basically, the idea is you don't want validators to have to store all of the data. You want to be able to share the data across the network. And that's what we're enabling with data availability layers. Now, others are talking about it, and they're talking about it for years. We're actually shipping it. And you can actually try already on the testnet these data availability layers. Interoperability, sorry. So, what are we building through the rollup? Well, Michelson rollups. Michelson is the VM of Tezos. It has a lot of advantages for the security of smart contracts, but a lot of people, they don't necessarily want to develop their smart contracts. They want to reuse some libraries. They've seen a contract they really like from Solidity. They want to remix that together. So EVM rollups for people coming from the Ethereum world who want the ability to run on Tezos. But that's, you know, Michelson, EVM. At the end of the day, those blockchain languages are fairly small communities of developers. We want to be able to work with Rust, with Go, with C++. So you can use those languages in order to build rollups on Tezos and build customized application. Now, L2 scaling, the way it's often presented, sounds like fragmentation. It's like, okay, you're going to be scaling, but I don't want to be on one rollup and you're on another rollup, and they have to communicate. That's slow, that's cumbersome. You want an integrated system. So how do we do that? And so the idea behind, and this is very, very, very clever marketing, Tezos 2.0. No one has thought of that before. But this is where we're going, and this is how you can get scalability and composability at the same time, the best of both worlds. So where is Tezos going? So ultra high throughputs. And really, sometimes when people think about throughput, they think about speed. It's like, what's your speed? 1 million transactions per second. We actually did a demonstration a few months ago at the TestDev conference with 1 million transactions per second, like for real happening. But this is really about cost. Fundamentally, if you're a business and you have millions of users, you're not even considering going on blockchain. And I think we haven't seen a lot of applications that could happen because of scaling. You know, we're still in an industry which after 10 years is still in search of product market fit. Why is it that with all the brain power, with all the talent in the space, there's still so very little that has been built on blockchain? And I think one of the answers to that is scaling, because not many people want to build an application that's only usable by a few thousand people, or that's only usable when the blockchain isn't down. So ultra high throughput, it's about cost, it's about being able to have many people use the chain. Low latency, you don't want to wait for your transaction. You want it to be included as soon as possible. Interoperability, you want to be using the program that you're used to. And composability, you don't want to be stuck on an app chain. You don't want to have to run your own infrastructure. You want to be able to just deploy and interact with the rest of the entire ecosystem. And that's the idea behind this UHT rollup. So it's one big rollup that supports many languages, so be it EVM for Solidity, Michelson for security, Rust, Go, C++. We can cover a lot of languages through this, but also provide really high throughput so that you can build really internet scale application, but do it at a very low cost. So where does that go further down the line? Further down the line, it's adding this data availability layer and separating the execution on this rollup from the availability. But in order of development, this is a project. Like right now on Tezos, you can deploy smart rollups. This UHT is going to take a little while. I think it's going to be probably in the next year or two that we'll see this type of application. But progressively, we're going to start with interoperability because that's the most important thing. We have communities of developers in the world working on blockchain which number in the thousands, whereas traditional languages have communities that numbers in the tens of millions. So program smart contracts in mainstream programming languages through virtualization. That means Python, the JVM for Java, Go, JavaScript, TypeScript, C++. If you cover that, and .NET, you cover 50% of the developers in the world based by GitHub numbers. That's a far larger number than Solidity. Anyone who tells you, oh, Solidity has one, it's a language of blockchains, that's ridiculous. It's tiny. The community around this around mainstream programming languages is massively, massively larger. Integrating blockchain into existing web applications should be as easy as importing an NPM library. And that's what we're shooting for here. Before throughput, really interoperability. Now, how do we achieve that? Because you might think, well, rollups, the whole point of rollup for scaling is you run them in parallel. If you're running into one machine, what's the point? What are you saving? Well, if you have one rollup, the trust assumption of rollups are way better than the one you have for just traditional L1 blockchain. In an L1 blockchain, you depend on an honest majority for your security assumption. With a rollup, you only need one honest and live party. And that changes everything. Because now that you only need one party, you don't have to have low hardware requirement to be decentralized. You can have very high hardware requirements if you want to secure the rollup, but then have the rest of the chain and the rest of the consensus be extremely decentralized. So the performance targets is 1 million TPS. I told you we already demonstrated 1 million TPS a few months ago. That was in parallel across many rollups, but in this case, we're targeting 1 million TPS on a single machine. So we're building on a solid foundation here. This is not a whole new project. A lot of the hard parts of building a blockchain exist in Tezos. There's a consensus algorithm that's worked, that's been stable for years now. There's a shell, there's a system for I/O, there's data availability that's coming, there's a strong community and ecosystem, which is the most important. So developers can build on smart rollups now. You can do that today. We have WASM rollup, and they're supported, and they're maintained, and you don't need anyone's permission. The code is MIT. You can build your rollup, you can use Rust, you can use Go, you can use many languages, and it actually works compared to, I don't know of any other rollup framework now today that you can use that works as decentralized. There's no breaking changes. The whole point is to bring backwards compatibility. The Tezos is about evolution, not revolution. Now, it's revolutionary in the world of blockchains, I would say that, but the evolution, the 14 upgrades we have over 5 years, they don't disrupt applications. Applications keep running, and that's the beauty of it, because your application on Tezos is future-proof. Why? Because Tezos will keep upgrading, so you don't have to worry. Oh, I picked Tezos, but is it going to be competitive, a year from now, 5 years from now? Yes. Not only has it been in the forefront, it has an ability to keep at the forefront. So what we're looking forward to, no discontinuity, a migration possibly of states to the L2, so more performance, more languages, more interoperability. And I think with this UHT rollup, we can have it all. Thank you so much for coming, and thank you so much for attending.